Right. Hello. Let's see. Oh, just have to move some stuff. Yeah. So actually, I did some more reflection on the useTransitionEffect, and I'm really happy about it. 15.1.0. Next. This is old. 15. Yeah. I'm trying to. I don't understand this. What was it? Command Shift. No. Branches. Change branch. Oh, it's Command Shift B. There we go. There's something weird about I created this branch that has starting refactor, but it's not popping up for some reason in the overview. Like, where the hell is my branch? And I would expect like it to be this one. You know what? I'm actually going to go down and get my computer to figure out what's happening here, because this might be a bug in yeah, 15. Just wait 2 seconds. Let's see here. So I was working on Elastic Sun. Elastic Sun. Do I have a branch called Elastic Sun? No. Why don't I have that branch here? That's so weird. What if I go to Family Scrum version 2, Elastic Sun? Oh, it's actually not here. Do I have to commit something? In the works. Okay, what about now? Let's see, let me refresh here. Oh, I actually have to commit something. That's okay, because we made this change to our branching so that we wouldn't actually create a branch on GitHub. But that means that we're not getting the branch on the dashboard either. Okay, this is something I need to note down. Let's see, new. Create branch should still appear on dashboard. Branch list without committing. Yeah, because I hadn't committed yet, so that's why it didn't pop up. But that's, I want to be able to move between devices without committing. So I consider that like a unwanted behavior. Let's see. Okay, so what I was doing here, let's open it in VS Code. Yes. Let's see, what were we doing? Command, I think, yeah. So I was basically just refactoring this so that it doesn't use the command pattern, but that it actually uses the commands here is toggle weekday and change weekday dinner. So we don't need any of this. Yeah, I think it just gives us what we want here. So currently, like, we're in planning mode and we stay in planning mode. Yeah, I don't actually think we need to insert a user ID there. We just check if it's the actual same. Oh yeah, user ID. Okay. Okay. So what happens is that when we change the weekday dinner, we go into a planning state again. And when we toggle a weekday, we go into planning state again. And this is really just to notify. Wait, there was one component I was working on. Which one was that? It was a grocery shopping. I wasn't done with that one. Yeah, so I added something here. So like the useTransitionEffect takes either a single state or multiple states. And that's about moving in and out of that state or those states. While when you give it an action, it's about creating a constraint on how you got into that state. But you might have multiple states as well. So in this case, we have an filter. Oh yeah, sorry. We need to actually, I think we should just release it. Yarn build npm publish. Because I'm really happy about how the API turned out. And every time when I've gone through the refactor now, removing the command makes me think about, am I actually describing all the states here? Which is exactly what forbidden. Let's try again. Nine, 5, 3. What the hell? 749 595. What the hell? Oh, it's the previously published, sorry. 623, but oh, so I actually have to bump it. Okay. Yeah, I haven't quite understood the tags thing. Bump for release. Yarn build and npm publish. So even though I'm using, I wish the tags had their own versions, but it probably doesn't make sense. It's just that I don't understand how to do proper versioning across tags. Previously published. What the hell? npm react states. What version am I at? 6.1.0. Why? Huh? 624? Oh, registry. Oh, god damn it. Oh, I don't want to mess around with this. 624? Do I have a 624 version? npm registry. What's the URL for the registry? I can't remember. There we go. Then I think React states. Okay, let's just bump to 625 then. bump for release again. This is the kind of stuff I hate spending time on this. I just want to build the stuff. Managing versions and all that, I don't like it. It's publish. Let's see. 759632. There we go. Okay. So let's see. We were here, and let's go in and add the latest version. Latest. Yes, exactly. So it makes me think about the states rather than writing less code. What the fuck? Why doesn't this work? Filtered. Oh my god, I tested this. Wait a minute, this should work. What the fuck? What the fuck? What the fuck? I hope it's just state. God damn it. Use transition. State current action. No. Why isn't it there? Oh, I forgot to merge. That's the fuck. Git merge next. Of course, there's a conflict, and this is why, of course, the versioning wasn't working. Merge. My bad, my bad. Yarn build and npm publish. Let's get this done. God damn it. Nine, 2, 1, 2, 3, 6. Okay, now we should be good. Now we should be good. Let's get back here. Let's do another install. And now we should have nice typing here. There we go. So again, it doesn't matter. Like useTransitionEffect either just points to state, which means entering and exiting that state, and then we have the opportunity to give an action, and that is entering this state, given this action, do this thing. So that's what I'm doing here. If I move into filtered or unfiltered, and there's some history to this view and how the state model is created, and I think I'll do a stream just reviewing how the state is modeled, because the two applications that's used for reference, they have a lot of history, and I have never looked back on how I modeled the states, so that's something to do for sure. But no matter, we have change weekday and toggle weekday, which currently uses command effect. No idea why these. Where is it getting that from? Nowhere. Aware that it doesn't. Okay. So we're going to use a transition effect instead. Why isn't it complaining? Hello. The file says there's an error, but there's no error. What the hell is happening here? There we go. Oh, TypeScript acting, or VS Code acting up. Yeah, so what we're actually doing here is that we're moving into planning with the toggle weekday action. When that happens, we want to go ahead and set the week task activity. And when we move into planning, given the change weekday dinner, we use the information from the action to set the week dinner. Yes. Cool. And then there's more commands here. And this is also weird. Like, why do I have to search again? I thought VS Code would update these searches. Anyways. So let's get this. Does use transition effect. We don't care about this stuff. So when yeah, not sure why this can just be state. So again, here I would actually here I would actually have a substate of like actually checking the version, but I don't have that currently, so let's not care about that. But let's see. So yeah, so use transition effect, signing in, we do a sign in. When we go to signed in, we check the version. When we're updating the version, we actually update it. And then we have this check version, where given that we move into signed in. Oh, this is an interesting one. Oh, sorry. So given that we move into signed in, given that we enter signed in by the action of the browser being visible, we also check the version. So this is the last place where I'm like, it's not 100% explicit, because now we're saying when you moved into signed in, given this action, we check the version. But when we actually do that, so here you can see it, when we're signed in and we have a visibility visible, we move into signed in again. But you would maybe do this, but then nothing happens because you're conceptually in the same state, but with a reducer, you're not in the same state. Like, it won't reconcile, so it won't run the effects. So you kind of have to re-trigger the same state, which is in one sense a little bit weird, but at the same time it emphasizes that you're actually not, you don't have a state correlated to this thing, right? So there's no state that reflects that we're checking the version. And maybe we don't want that, so that's correct in this case, but I would suggest that we actually do want it. So when we check the version, we would actually have either a substate for that, or we could even have an overall state for that. Because you might want to show it in the UI. Like now we never know if we're actually checking the version by looking at the state, but that's something you might want, right? So in that case, this will be exactly the same. It's just that when you do the sign in visibility visible, we would actually go here and say state version, and then we have like version states. Oh, do I have that? Oh, by the way, these, we're not going to have these. Yeah, pending. Oh, I actually modeled it this way. Why don't we? Oh, is that why? I didn't know that. I actually have that substate, version states. So it actually tells if it's pending, if it is the recent, or it is expired. Are we doing this? Are we actually changing this? Yeah, we're version states. Well, that's the one. Yeah, exactly. So version new. Yeah. Okay. Okay. And then it makes sense. Anyways, sorry about that. Let's continue. Oh, there's a lot of commands here. Toggle checklist item. Yeah, this is going to be interesting. Let's take a look at how these are. So archive to do. Oh, no command for that. Wait, isn't there any state related to that? Did I remove something? Wow, this is weird. When we are in a to-do state, and to do with checklist, which is this use to do item. I find this a little bit weird why we don't have the actual to do there, but maybe we don't need it. Yeah, so this is also interesting. Like here we archive the to do, but I just moved back into the to do state, but you shouldn't be able to archive it twice. So this should be archived to do. That should actually be the state for it. So that's definitely just wrong. To do with checklist. Yeah, I can't remember how this actually worked. Yeah, let's see how this ends up looking. Yeah, so, oh, this one's interesting. Yeah, this is interesting. So if we are to run a side effect of actually adding the checklist item, no, it's good. It's good. Yeah, this is actually good. So yeah, this is so interesting. So what actually happens here is that if this action is invalid, so for example, if the checklist is collapsed or adding the checklist item view is inactive, we just return the same state, which means that nothing happens. So it won't run the side effect either. So when it actually runs the side effect, that's when we have a valid action. Yeah. That's interesting. Okay. Oh, what's happening here? I suddenly felt dizzy, and it was because my pointer was laggy. No matter. Blah, blah, blah. Oh yeah, let's remove the last commands there. I think something wrong with the... Is it... Okay. So let's see how this works. So when we are in to do, yeah, here we can use the same. If we are in to do or to do with checklist, so this should really be an explicit state. So what we're saying now is that if we're in to do or to do with checklist and we have an action of archive to do, we actually archive the to do. But this should be an explicit state because it's the final state, right? When you click archive, you shouldn't be able to do anything more. It's the final state. So all actions are invalid at that point. So that's something we can fix later. And then we have useTransitionEffect. Again, toggle checklist item. So this is only valid in to do, let's see, to do with checklist. As I said, if you toggle a checklist item, it's doing a matcher that we actually have it open and everything. So it's actually only valid when we can take a look at this. Oh, that's actually not. Yeah, that should really have a check. So like match state checklist. So if it's collapsed, we don't do anything. If it's expanded, because you have to have an expanded checklist to actually toggle that. And you can argue like, why the hell do we model this? Does it really matter? Isn't that more of a UI thing when you should be able to toggle the checklist or not? But we're just describing the intention. And the intention is that you can toggle checklist items when you have expanded the checklist. And again, we're just moving into the same state here. And the thing that's the reason this is a little bit weird is that typically we would actually have the checklist state in this reducer. So you would have like an optimistic version in the reducer, and that's where you would manipulate the state. And then we would rather have a side effect that would just store any changes to that. But because of history and the way this is handled is that we have a central state store instead where all the data is. So each reducer doesn't manipulate its own state. It rather manipulates the central state store. So there's no optimistic version which you save eventually. You just directly manipulate the central state store, which is why it doesn't actually make any change to the state other than just confirming that this was a valid transition. But yeah, that's the only thing which is not intuitive. Like working with explicit states and state machines, you can argue that's not intuitive. That's something to learn, but when you learn that, it's still not intuitive that, okay, I want to implement toggle checklist item. Okay, I want to ensure that the checklist is actually expanded. And when that happens, I just want to move back into the same state. Like, it seems like you're not doing anything, but what you're doing is that you're basically just indicating that it was a valid action. Yeah, this is interesting. This is interesting. And then what happens is that there's a side effect that actually takes that action and changes it. So we are just guarding the action itself. One thing is guarding, yeah, it's, yeah, there's something here. And you could argue it's the way I've modeled this. But maybe there's a better way to express this. Yeah, I'm not perfectly sure. So delete checklist item would be when we have it to do with with checklist. That's when we can do that. And again, to do with checklist, that's when we can add a checklist item. And I think it's called what's it called? Oh, where's the title? Is it here? Ooh. Where is this title coming from? I think it's actually coming from the checklist. Oh, this is interesting. Oh, yeah, this is definitely, because now I have a checklist, but I like the reason this action was okay is because the checklist, like we can take a look at it. Yeah, there's something still not working here. So we have a new item title, which is when the add checklist item is active. That's when you're actually able to, that's where we store the item title, which makes sense. And that's when you're allowed to like add a checklist item and so on and so on. But when we actually add a checklist item, we make sure that that's only valid when you have an expanded checklist and also you have an active add checklist item. That's when you should be able to add it. But the problem is, even though we know about that here, when we do the check here, we have no idea. So here we would actually have to do the check again to find the new item. So I guess this is where we didn't quite get there. And I published it. Well, it's way better than commands, no matter. So I'm not worried about that. It's just, I keep getting to this question of maybe I would have modeled this differently if I had the use transition effect from the get-go. Yeah, you know what we should also do here? New item title. If we have a new item title, then we actually allow it. That's also something we want to guard. But yeah, I don't like the fact that I actually have to. And you know, what also happens here is that we make it inactive. So we actually remove the state. So we don't have the new item title anymore. Yeah, this is an interesting one. So, like, you could argue that we shouldn't even keep the new item title. It should just be passed on the action, which would have solved all of this. But there's this thing of, there's some expectation here that something should happen. But it's expressed as just changing the state. it's so frustrating. So conceptually, what actually happens here? Like you're adding a checklist item, and in terms of state, yeah, and I even wonder if I did have internal state of the checklist items, I would just concat it, which means that any outside effect wouldn't know exactly what I added, right? Unlike if when I had the command concept, you could just explicitly return the thing you added on the command, but you don't have that anymore. That's the bad thing about being reactive. Like you have to interpret what happened. You don't get like an explicit, hey, this is exactly what happened. And then you can say that, okay, we embrace interpreting the state, like the reducer should only care about state, it shouldn't care about side effects. We're embracing that, which means you need to model your actions and state so that your side effects has the information they need to run. So in this case, I would state that in that concept, you can't store the new item title in your state because we want to use that when we're adding a checklist item. Yeah, and this is the tricky thing about the substates. They're not part of the main state, so you can't really, when you do transition effects, you don't know the state of the substates. Like you have to re-evaluate the substates. God damn it. God damn it. I'm not getting, like, I just want to, every time I do an iteration, do feel better about it, but it's not quite there. There's something icky about this still. But the thing that drives me here is that I know what we're doing is that we're making things more predictable because we're creating a reducer where we actually decide what should be allowed to do, which is what you don't do normally. You just say, given this action, make this state change. And then it's up to the outside to choose what state the reducer is in instead of the reducer itself. So I know, but the goal is to make it like intuitive and straightforward to make it safer and more predictable. And we've gotten so far with like entering, like when you have a simple state, like a relatively simple state, like you don't have substates, then it's like super straightforward. But as soon as you get into substates and you have these side effects where you're still in the same state, then it starts getting hairy. Yeah, so this project is actually something that has gone through many iterations. It's kind of a test project for this state machine concept, and it's actually an app that I built for my partner and me, because we're very different. I'm extremely laid back, and I do things like when I think of them. I don't plan ahead much, but she's a planner. So I built this app called Family Scrum, where we kind of sit down one day a week, and we just, and the point is that through the week, so part of my personality is that I hate talking about stuff and planning stuff all the time. I just want to code and relax and just enjoy life. Well, she has to get her thoughts, like she can't control herself. She's thinking about stuff all the time. So as a compromise, I built this app where she can just insert whenever she has a thought about something we have to agree on or plan or whatever. She just puts it into the app. And then one day a week, we sit together and we go through all of this, and then we kind of commit to doing things. We plan the next week. And it's actually worked really well for us. But anyways, it's quite complex. So if we get through this, I'll actually run the app. But yeah, I have to reason beyond this thing where we either have a substate or we just have a state that doesn't change, but because of the action coming in, we want to do something. But because of the action coming in, we want to do something. Which is the case here. I could just move the new item title. That wouldn't be a problem. Maybe we should just do that here and keep exploring, because I don't want to get stuck on this. Let's see. Let's just change that. So there is no new item title here. It's just changing to an active state. And then when we add the checklist item, we have a title that we pass in. So that's like UI state. So we don't do this. We just always, so whenever you add a checklist item, we disable the adding of the checklist. And then it's up to the outside world to use that title for something. Yeah, we have the same here. Change. Oh, and there I actually passed the title. That's interesting. Change new checklist item. Oh, that's it. Yeah, but it doesn't have to be like this. Yeah, so here we used to pass it in to put it in here, but we don't have to do that. So change new checklist item title. Oh, I wonder how this is going to look in the UI. Because now we... No, wait, it should be the same. We should pass change new. How should this be? Yeah, but we just, yeah, exactly. But why is this active? Like change new. Oh, sorry. Yeah, of course we don't need this anymore. Sorry. I thought this was changing an existing checklist item, but this is actually updating the title we don't have anymore. So we can actually remove that. Sorry. Yep, it's not there anymore. And then show a checklist item. This is UI state. We just activate it. And now we don't care about this. We just care about the title coming in on the action. So we have to fix that later in the UI. Oh, we can actually fix it now. So this would be, what are we actually working on? Use to do item. So in the UI, this should break now. We expect that we actually have a title here, but we don't. So we need to add a local state for that. This is actually starting to blow up quite a bit. So what we're going to do is we're going to move this into its own component. Let's see. We're going to call that add checklist item. On add, we do add checklist item. Okay, so let's create that component. We'll just create it above here. What did I call it? Add checklist item. And what does this needs to be like this, because we need some internal state for it, which would be title, set title, which is empty, and that will be title. And what this wants to have is on add, which is just the title on add, and here we just, yeah, so on change, that means we change the title, and then we do on add, where we give it the current title. Okay, oh yeah, we need a translation service here. Cool. Okay, so what we're going to do now, we're actually going to run the app. Yeah, let's see if it actually runs. Okay, let's restart. Let's see, are you running? Compiled successfully. There we are. So I have to move to this screen because I have to log in with my, maybe we should see this in mobile mode. That's a weird phone. There we go. Okay, sign in with Google. Yeah, so this is the app. Yeah, so you kind of see, we kind of get to the, yeah, we're supposed to put out some garden stuff. Yeah, I think we already did this, so that's great. Anyways, so we have like a shopping list here, and I had a bug here. I was actually shopping yesterday, so let's see if it's fixed. Yeah, nice. Now I can remove them. I couldn't actually do that previously. Cool. And then we have like this plus down here. This allows us to add something new. And then we can go in here and we can do like plan next week, where we plan our dinners. So we just kind of slide them in. This is actually a recent feature. We haven't really started it. So we're testing that now. And then we have like the to-dos. And then it's actually filtered on what did you plan last week, what events are happening next week, what can you do next week, and what are future events and stuff like that. Then we kind of go in and then we commit ourselves to doing that a certain day next week. And then if the to-do has a checklist, it actually pops up as a checklist. So this is an actual to-do, but it just has a checklist attached to it. So this is like our daughter and me, we're going to visit my mother. So you can see that there's a checklist of bringing the iPad and a headset. And then I can go in and I can edit it and stuff like that. So let's let's go in and just see if the checklist is working. So maybe we can add something. But wasn't the checklist something you activated? Oh, this is interesting. Is that a different state? Yeah, so I think there's testing. Yeah, so here we are. Adding a new to-do, blah. Oh, but it's always showing. Oh, maybe that was old state. Yeah, there's probably history here, because there used to be like a button underneath there, like add new item, which isn't there anymore. I think I changed this UI without changing the state. But it is working though. Yeah, what the hell? No, here it is. Sorry, that was a different. Yeah, sorry, I'm confused. The state we were working on is this one. So add new item, test, add, and that didn't work. Okay, so we did something wrong here. Let's make it bigger. So which one is this? Here it is. Okay, so we did show add checklist, but it doesn't seem like it did the call at all for on add. Oh, why? This is weird. Why isn't this? This should actually give an error. That's fascinating. Why doesn't TypeScript yell at me? Because this is actually invalid. It should be title. Oh no, it is correct. Sorry. Oh, sorry. Yeah, it is correct. Oh yes, I know why. It's me. This should actually be a dispatch. We're going to dispatch that title. And that's why nothing happened. So if I try again now, there we go. It's added. And I can even remove it. Awesome. Okay, so this is running now. Okay, cool. And now we're wrapping this up. And we had that snag with, yeah, when you have a state, you have an action, and you want to run a side effect of that action, but you have to like move back into the same state to trigger it. And that's the guarding. It's like if you move back into the same state, but you define it as like a new, you just make a copy of the state basically, that will do a reconciliation in React and it will actually run any side effect. But if you just return the exact same state object, it's a guarding operation. Like it won't run that side effect, which is very implicit. I wish that was more explicit. That's the thing I'm struggling with a little bit. Is that there are these scenarios where the action doesn't do anything with the state, but it's still a valid transition. So you could argue like, why the hell do I even have that action? Like from the perspective of the reducer, why do I have that action? It doesn't do anything. So for example here, archive to do. Why do I have that action when it doesn't do anything with the state? Well, it's because there's a side effect to doing that. But that's very implicit. So in this exact case, it should be an explicit state, saying archiving to do, and that's the thing you would actually, then it makes a ton more sense, right? Because then you're saying the state is archiving to do. The reducer doesn't care what happens. That's some side effect will deal with that state, but you moved it into archiving to do, and nothing else can happen to that state. It makes a ton of sense. But then you have like, okay, I'm going to toggle a checklist item. Okay, you're only supposed to do that when the checklist is expanded. Makes sense. But when you do that, nothing happens. Like you just move back into to do with checklist with the current checklist state. It's like nothing really happens. And that's what I don't like. You're just saying, okay, the action is valid, but I'm actually not going to do anything with it. It's up to the outside world to do something related to this. It would make a lot more sense if we actually change some internal state, like we added the checklist item to the internal state, and then the outside would do something with it. But we don't do that. Yeah, and that's also a thing. Like, what if the action passes parts? So what if the action passes in some param that's evaluated and then included in the state, and then you want to do a side effect on that. But now, like if you had a command, you were actually able to take that evaluated state and pass it on the command. But now you can't do that. You can only say this is a new state and this was the action causing that state. You don't know, you can't pick up that thing you changed. Ugh. It's almost like yeah. Yeah, I don't know. God damn it. It's like, what if you had there is this other library. It's actually built by the same guy who built Xstate, where he has something called commands, where it's actually, you do something like this and you actually call it. You say like, like you add a command. But then the concept changes. Then the reducer actually cares about the outside world. It kind of tells the outside world what should happen related to a state change. Oh, I'm struggling so much with this. How I think about this. Oh my god. So here you would do like, so you wouldn't actually change the state. You would just return the existing state, but you would say like commands like add whatever, delete checklist item. Like it could even be something like this: delete checklist item. The problem though that you shouldn't. Yeah, it's about clarity. It's such. Yeah, I'm going to adopt that word, clarity. It's being explicit. It means kind of the same thing. I'm talking about being explicit, but clarity is kind of explicit is about more writing the code, but clarity is about reading the code. Oh, this would be called a partial acceptance of presented state. Yeah. In SAM, what's SAM? Yeah, I should. Is this it? AWS serverless? SAM? Oh, state machine. Is this it? Maybe a SAM template? Partial acceptance of presented state. Oh, SAM pattern. Oh, okay. State action model is a software engineering that helps manage application data, blah, 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 precision and clarity. Modern. Simplest. Partial. Oh yeah, partially accepts or rejects the proposal. Yeah, exactly. It's yeah. I think the biggest problem here is that like React States tries to do the minimal thing to a reducer to reflect the concepts of a state machine. So that if you have a reducer, you should easily be able to like refactor it. So it creates a lot of constraints, which is also the fun part on this. It's like, and the constraints are, it can't be imperative. You have to actually change the state reference to cause a reconciliation to run side effects. So it just minimizes your ability to express these things. And I get, yeah, again, that's kind of the fun of it. It's like taking these concepts, which you can easily express with mutation and imperative APIs, and kind of see how you can express that with like an immutable, more declarative reducer. Yeah. But the model partially accepts. I wonder about this partially accepts. What's partially accepts? Is that like an explicit call? Accept. Is that where you accept? Partial. Oh, it's the same. Can I search here? Partial accept. I don't understand partially accepts. Search partial. Reject or partially rejecting. How can you partially accept and reject something? Oh, is everything on one page? Oh, I see. Yeah, that I still don't understand what partially means. Let's oh Is this TypeScript? Yeah, or VS Code. Anyways, I'm going to just let's see. I'm going to just push this because this is working now. Refactored to latest React states. Yeah, I can just open pull request. Refactor to latest React states. All checks have failed. Okay. What did I do? Oh, and there's use plan next week. Didn't I push all of it? Oh, I didn't actually. Oh, there we go. Yeah, partially accepted. But what is the partial part of being accepted? Is it parts of the new state? Parts of the proposal? Yeah. Yeah, because the proposal, in the way I think about it, is an action. Because the model is a counter, and the proposal is to increment by 1. It's like you have an action of increment by 1. And either that action can be accepted or it cannot be accepted. I don't see how can an increment by 1 be partially accepted. Maybe just partially accepts it doesn't make sense in this example. Maybe it needs a more complex example. Like you propose multiple things and then you just accept some of them. I would assume. Yeah, and then reactor, which is kind of which is interesting, which would be like use transition effect. To factor a model as a series of acceptors and reactors. Acceptors validate proposals and mutate the state accordingly. Reactors react to state mutations and are not involved in the processing proposal. That's very interesting. Like conceptually, it's like proposals are actions, models is the reducer state, and reactors is the use transition effect, like conceptually. But how they operate like in the code is of course very different. Yeah, and then compute a new state representation. Yeah, so I guess this is like, this will be the component. Let's see. Okay, cool. Now this is okay. I'm going to merge that because I want to look at this other thing as well. But I love to talk more about Sam. Always happy to learn new things. Yeah, and I'm going to reflect more on the like it lacks clarity on when you add a checklist item and you just stay in the same state. I wonder, like in terms of in SAM, you would propose to, I guess you would have the same problem here. Like you propose to add a checklist item, but it doesn't actually change the state because the reactor is the only thing that cares about that. So I guess that's the thing here as well. It's like you're sending an action to add a checklist item, but there's no state that's related to adding that checklist item. So it doesn't actually, the proposal isn't for the state. The proposal is for the reactor in this case. Yeah, and they are not involved in processing proposals. So that's the thing. And so I think this issue that I'm seeing is that if I had just used TransitionEffect, I would have modeled things differently in the beginning. So it's a lot of history going through different ways of thinking about stuff that kind of made this, because it's the only thing that hasn't made sense up to this point. It's that specific scenario. And as I pointed out several times, is that the state model is wrong. Like, it should have moved to explicit states. It shouldn't have stayed in the same state. And then again, like when you're editing a to-do, you most certainly want to like pass in a copy of that to-do to the reducer that actually deals with changes to it. And then as you, and that's the thing, that's the tricky thing, because I'm not like making changes to a copy and saving it. I'm just, for every single change I make, I just go directly and store it. And then the way it updates is not because I have a successful update in my storage. It just assumes it's okay because it's so fast. The store updates immediately. Yeah, it's so interesting. So it's kind of like conceptually what we were going through was that the states we were trying to deal with was only related to UI. It wasn't really related to the to-do itself. It was just guarding what actions are valid in certain UI states. That is what we were doing. And maybe that's enough. Maybe that is enough to just say that certain actions doesn't make a state change, but they are still guarded, which means that if the action is valid, it produces the same state again. It makes a copy of the state. But if it's not valid, it returns the exact same state, which means that it basically blocks the action. That's the implicit thing in a reducer. Blocking is returning the same state object. It's not going into the same state. Yeah, hi. Yeah, I was just talking about the partial stuff. It might be that the proposal is kind of too simplistic to understand what partially means when you increment by one. But the proposal, I would suggest, could be like you could have multiple things in one proposal. So maybe increment by one, and you could also have something else you propose. And then you would accept the increment by one, but you would not accept the other thing. Yeah, I would like to see an example of that, but at least that's how I think about it. And also what's interesting about this is related to what we went through. It's like the model is the reducer state. The proposal is like the action, and the reactor, what's it called? Reactor is like the useTransitionEffect, like conceptually. Like they don't work the same way, but it's conceptually the same thing. And then representation is the component. Yeah, exactly. Yeah. So I think, yeah, like I'm kind of summarizing in my head that there is this where it lacks clarity is that with a reducer, to express a no-op, like a blocking behavior of an incoming action, you return the same state object, like the same reference to your current state. But if you want to say that the action was valid, but you're staying in the same state, that means that you produce a copy of the same state, basically. That's how you accept the action within the current state. But it just lacks clarity. You don't say accept. You just produce the same state again. That's like the implicit acceptance, where I wish it was more explicit. Yeah. Yeah, it's very interesting. But maybe that's a good transition to this other thing I've been playing around with. Which it's the same concept, so we can definitely continue the conversation. Let's see. Didn't I add it to... I thought I added it here. Isn't it here? Timsy? There we are. It's called timsy. And maybe we can... Yeah, let's add a new branch here. So this is just for fun. Like, I can't help myself. I always have to like conceptualize things into something. Like, I can't just play around with syntax. It has to become a thing for me. Yeah, this is why the model is so important. So the thing about timsy, did I have some documentation? Maybe we could write a little bit of documentation so that you get an idea of what it is. Yeah, maybe I can just write, it's not even TSX. So create states, create machine. So it's like an agnostic functional state machine with epic type support. So this is just, I learned so much moving through React states that I wanted to not live in the constraints of a reducer. And not having to, so with a reducer, you have very explicit typing. Like, you explicitly type your state and you explicitly type your actions. And that's what you type on the arguments of the reducer, like the state and the action. And I wanted to bypass that. I wanted to make it as simple as possible. So this is like timsy, and timsy is like TIM, or like Tim is like the incredible machine. If you ever play that game, it's amazing. And then SY at the end, that's something I just put on all my packages, like formsy and all that kind of stuff. Anyways, so the way this works is, and maybe I can make it a bit bigger, is that you would say states and you just create, and the thing I don't like either is that you explicitly have to type the state property, but you don't really care about that state property. So in this case, what you do is, oh, what happened here? You just say, I have a foo state, I have a bar state, and this will automatically produce that property for you. You don't think about it, you think about them as states. But whatever you return here will actually have an added state property with this key. And then you have your machine, which is create machine. And what you can do now, you can just pass the states and it's typed for you. So you can say foo and bar, and you don't have to type the actions. You just say, okay, I want a switch action here. And this switch action should move us to bar. And then the same switch action, sorry for not having any highlighting here, moves us to foo. So the first function here is the actual params for the action. So if I were to say like an n number here, it would you would be able to call this from the outside with the number. And then the function you return has the current state. So this is the current state. And all you have to do is say my machine, and you call it with the initial state. Currently it's a callback, but we're going to change that. And then you can say my machine events switch, and it's typed a number. So the point is that it's like, it's very precise. You don't have like 15-20 lines of typing, and then you get into the implementation. You just implement it, and then you get the typing for free. And but anyways, let's see. So you have like my machine events, and you have my machine get state, which gives you the current state. And then you have my machine subscribe. That's all it is. And it gives you state, event, and prev state. And that subscription gives you everything you need to create any kind of reactiveness to that machine, because it gives you the current state, the event producing that state, and the previous state. And it even triggers if you return the exact same state reference. So if you wanted to like do nothing, when you return the same state reference, you would do like prev state and then return, don't do anything. So it's like super low level. But that's all it is. It just, and what's cool about create states is that you can also do substates. So you can have some substates you create with create states. And then, so for example, you could do substates would be create states, foo nested, whatever. And then what you could do then is, okay, to produce foo, you have to pass in a substate. So maybe we can just do that. Substate would be, and this is a little trick I've learned. Maybe we can, so type substate is return type of substates, key of type of substates. So this actually gives you, it actually makes this a union. All the substates becomes a union. So you can do this substate, and now it actually requires you to pass in that substate. Anyways, so you can do substates here, which is important. And again, with like minimal typing. Now, what I thought we could do, we should change this initializer to not be a function, but just take the initial state. And then I wanted to create a React abstraction on top of this, just to play around with how would that look like. So like the core is just this. It will always be just this, but then you can create an abstraction over it, like hooks for React, Svelte, you might do something, or Vue or whatever. But that's like, this is all it is, which I like. Yes. Should I do anything more here? No, I think that's okay. The question is, how should we add that React thing? I thought about adding a directory here, React, and write tests, but maybe we could rather play with it in CodeSandbox, because then we can like explore it a bit more. But let's see, the initializer, this should be this. Let's see, state machine. So current state, initial state. Yeah, we shouldn't even call it initializer. We should call it initial state. Where did it go? Initializer, initial state. There we go. Yeah, let's see. I think I have some tests here. Didn't I have some tests? What the hell? Yeah, just not found. Oh, didn't it install the dependencies? That's weird. That is weird. But yeah, related to like SAM and stuff, like there's an opportunity to be more explicit. Like you could imagine, so you can imagine like the proposal coming in here. This is the proposal. And then instead of having state here, you could have like accept, reject. Let's see. Yeah, this is interesting. So you would have proposal, and then you would have like the, I don't know, like the state, or like the model. Let's call it model instead. And then you would actually, yeah, maybe you could even have model. So you would do model accept or reject. That's interesting, right? You kind of just with that tiny change, you suddenly have a SAM thing. Maybe we could play around with this. This is fun. Let me try to understand SAM, and let's make timsy a SAM thing. Let's do SAM terms. Yeah, so this is interesting. It is. Is there SAM challenges? Is isolating application state mutations? Yeah, so you have an action acceptor, reactor, next action, and or state represented. Yeah, so this is just going through the subscription. And you'll have to excuse me. I try to. I'm kind of learning this as we're going. Validate proposals and mutate the state accordingly. Where does it actually? So accept proposal. What I don't quite understand is, where does it actually express that this increment by 1 is going to make an addition? Yeah, I have to be careful. Yeah, I have to be really careful. But this timsy thing is just solidifying some learnings to play around with stuff. So yeah, who knows where things end up. But I'm wondering how is it inside? Do you define the accept on the model? Oh, here we go. So you have a counter. Is there like there's a model. Okay. Model.present. Yeah, so you get the proposal into, so the model is really, you kind of implement how to evaluate the proposal. Derive the current control states of the system, counting model, counter max, state representation, model render. system is an invalid state. Yeah, I'm trying to quickly infer the acceptance. Yeah, actions create the proposals. And then the model accept here is that like the proposal isn't like it's not a proposal for, yeah, exactly, they propose new state, but they don't pass the actual new state. So it doesn't say like counter should now be 5, for example. It's more like, please do this. Increment the counter by 1. And yeah, maybe I can look at the library. Maybe it makes more sense there. Oh, yeah. And initial state. Intent, that's also a good term. Like they're not actions, but they are more like intents. Yeah, so you have the actions. Okay, here's the model, the proposal. Okay. Oh, so you have an acceptor. But how do you know which you're sending a proposal? Okay, so it is basically, so in this case it's not like accept, it is kind of just returning the new state. You don't really have to like say accept, like I guess that's kind of what I'm exploring, like how can it be more explicit about, so there has to be logic here, and so it would kind of be, yeah, so let's call it proposal model, and if the switch is good, you kind of do, this is an accept, implicit accept, but you could also, yeah, well, yeah, I guess that's the thing. Like the proposal here is the action itself. Like you have the action itself, and this is the proposal. So that's how they term it. It's like you have an action with a proposal. So I guess that's, we could say the same here. We have an action with a proposal. And I guess, but isn't an action a proposal in itself? Like, what if the action, but maybe that's kind of the part of the concept here, is that you don't actually, the action, like here we say switch, which is a proposal. Like the action itself is a proposal. There's a proposal to switch. But yeah, I was wondering if there was a way we could, so one thing I did at the point is that I actually had something called no-op. So is awesome. I'm just putting something there. You would do states bar, or you would actually call no-op. And it doesn't do, like the only thing it does is just return the model. But it gives clarity. It's saying that nothing should happen instead of doing this. Like it doesn't say nothing should happen explicitly. But it's kind of it's not needed. Yeah. States.bar. Yeah, it's interesting. Yeah, I would just wish there was a way to be more state has our clear ours. Yeah, because this is thing here, it's like very imperative. Oh, yeah, this is interesting. Here we go. Initial state, status ready, history. Component. Yeah, I didn't read what a component. Oh, so I guess this is more. Yeah, the predicate thing. I kind of jumped it because I was searching for something else. Maybe we could look into that. So here, yeah, this shows it very nicely. You have this action. It's represented by an array, but you could imagine it having a key, like our switch. So you want to. Yeah, I can't help myself. I get very impatient. But I wouldn't think it as like rushing in a straight line. I'm kind of running in tiny circles. I'm moving forward, but in a circular manner. Yeah, exactly. And actually, it's funny you say that. I've been reflecting on that quite a bit because I do rush a lot. I jump past details because I'm very, very impatient. And it even happens in conversations as well. I have a tendency to like be impatient in the sense that, oh, I have something I want to say, and then I don't listen as well as I should. And I'm very aware of this, and I know it's not good. But my strategy is to kind of, yeah, as I said, kind of going in circles, going back to stuff all the time, because what happens very often for me is if I go in a straight line, I haven't taken the right step. So when I meet something, I don't understand it. So when I do the next thing, I don't have the best start to understand the next thing. So I kind of make sure that I always, yeah, it's a loop thing. It's like an event loop for me. Well, that's not the right term, event loop, but it's a loop condition for me. So I'm kind of strengthening my understanding, kind of going in loops, but forward loops. Anyways, but acceptors, and so this is a great example, I think. So you have the acceptors where it basically just checks if you have an increase by, it will do that. And then you have reactors. Yeah, so that would be like, you could subscribe to the, a different way to deal with this is you would kind of subscribe to the save SAM from the outside. And then whenever the model changes, you would check the counter. But what's interesting here is that the reactors are actually changing the state. So actually, yeah, so both of them are kind of, yeah. So you have acceptors changing the state, and you have reactors, or like you have acceptors changing the current state, or maybe I guess this also could change the status, right? It doesn't matter. But the point is that you have reactors that can do the same. So you kind of have two steps to the process. So if we look at the code here, we only have the the acceptors. The acceptor stage, where we are, the reactor stage is just a side effect. You're kind of out of the world of the machine. But that's interesting. That you actually have safety condition when true will roll back to the latest safe version of the application state. Counter value is dangerously high. That's funny. Yes, I think like here it's just it's like mutation and imperative. Whereas if you did it more of a functional declarative way, you would actually like you would get state here, and then you would return that state with the updated counter, or you would like kind of like a reducer. So you could think of this as a reducer. That would be also a way to express that. But if that reducer actually returned a new model reference, like even if it's the same state, you're still in ready, but it would increment the count. It will trigger this reactor because the increment has changed, and then this could also return a new, like this is also a reducer kind of thing. So basically in the thingy here, this object here is the acceptors, and then you would kind of need to do, I guess that would be an array or something. Why is it not moving between the two? Anyways. Oh, of course. No. Yeah, anyways. Yeah, so this, it's an array. So you could have like multiple reactors. Yeah, so it's kind of merged the actions and acceptors. It's like, yeah. So you have the action defines. Yeah, exactly. It just, yeah, it's kind of preset, the action. Yeah, well, no matter. It's very explicit. But I do wonder here, like the acceptor doesn't care about what action comes in here. It's not like saying run this acceptor with this action. So I guess you would have to interpret here what action you're getting. I guess you could have like a type on the action, but then you would kind of have to switch. Or is it array based? Like index 1 is handled by acceptor 1 is handled by reactor 1? Or 0? No. Asynchronous actions. Oh. So you even define the logic within the thingy. Yeah, that's also different. Like here you actually define. So if you did an HTTP request, you would actually define it inside here. Because there's a difference here. Like here it's expected that if you were to do anything async, or fetching or whatever, some side effect, it's like outside of the thing. Oh yeah, so here you have test if. Okay, so yeah, so it's just instead of having an explicit action type, it just checks if the property is there to figure out what is the actual action I'm dealing with. I will have an explicit action type. Because this is hard. This is like, it's very explicit, but I feel this is less explicit. Like, which action are you actually dealing with? By naming the actions, or at least giving them a type, you would be more like, this is the action I'm dealing with. And with TypeScript, you would get the correct properties by checking the type. Anyways, no biggie. Yeah. Okay, so we didn't really get to that. Yeah, it's interesting, the SAM thingy. Especially that when you have a reaction that actually wants to change the state. Like, one thing is having reactions that are side effects. But having reactions that actually changes the state. Yeah. Because the thing that bothers me a lot, especially with React, is like you have, well, I guess we don't need, it's like you have fetch. Like, you create this function, you go do fetch. You go and fetch something, but before fetching something, you want to put the machine into fetching state. So you would kind of say machine, or in this case, my machine events, like fetch, for example. And the thing is, like, it doesn't compute at all this, because you kind of want to move into a fetching state, and then you want to do the fetch, and so on and so on. But this might not be valid, but you're still doing the fetch, and so on and so on. So that's why you really want to make it a reaction. So when you do fetch, you just pass that intent into the machine, and then you're rather reactive to the machine. When the machine actually moves into a fetching state, that's when you start the fetching. But where was I going with that? Where was I going with that? I don't think I were going anywhere with that. I guess we're kind of back at this scenario again, where like, even if you just had this, like, either you do something with the current state, or you say accept, which means, yeah, this is interesting. Or you could say reject. So the point is that accept means, okay, accept this. That's the point. Like, the proposal doesn't do anything. But it accepts, like, if you think about the, in this case, it's called events, not actions. What you're accepting is the event, but the event just doesn't happen to change the state. And you could even, and you could actually even have them as, like, you could say accept state or reject state. They could be like functions outside where, and this is the thing, like, it doesn't, like, accept, yeah, exactly. There is no harm in it. It's just, I don't know why it bothers me so much. I just don't feel like it's just so implicit. yeah, I'm trying to find like the terms for what I'm thinking. But just doing this, like, so this switch, it's kind of weird that it's switched now, but imagine that, okay, we have this switch event and we want to be explicit about this switch event to be okay. Like, we accept this event coming in. It's not changing the state, but we accept it. It's a valid event for the current state of the machine. So by having accept and reject, the only thing accept does is this. That's what it does. And reject does this. That's the thing. Like, what's most explicit? Is it doing accept state or reject state? Maybe that's even weird. But the point is that this doesn't really tell you why you're doing it. Because if you were doing just state, you wouldn't know from the outside if that event was okay. Was it okay or wasn't it okay? Like, you have to do something to indicate that it was okay, that event. Yeah, so this is the case where, so let's say it was add to do. So the add to do didn't actually change the state. There's some side effect that adds the to do. And then you just want to say, okay, I state now that add to do is a valid event for the current state of the machine. I'm not going to change the state of the machine, but the outside world has to know that this was a valid event. Yeah, yeah, we should talk live sometime. That would be fun. I have a 1.5-year-old sleeping downstairs who's about to wake up, so I have to go shortly. But I have the possibility to invite people to the stream as well, so we could do that as well. But yeah, I guess this is just the thing that's bothering me. It's not like the concepts. It's just that, okay, I have a subscription here and I want to add a to do. Like, I want to store call add to do on storage or something. So I go in and I say add to do here. Maybe we could just keep this and then. So I have this subscription to react to the machine and I do add to do and I have some info about that to do. So that goes in, the machine says, okay, I am actually dealing with add to do's here. That's perfectly valid to do that, but we're actually not going to do anything about the state. We are just going to accept the event as a valid event because there's some subscription that is going to actually act on that event. It doesn't really care about the state. It just cares about the proposal. Is it a valid, like, you, as I guess in the terms of SAM, it's like you have a proposal that is valid, but it doesn't change the state. It just goes straight to a reactor. That's the thing. That's the thing. That's the, yeah, now I was able to explain it. So you have an action here. Oh, you don't have a reactor here. Okay, maybe we should go up here. So you have this increment by 1. So imagine that nothing happens to the state. Like the proposal doesn't do anything to the model. But the reactor actually cares about the proposal. And that's the thing. Like, is that a real thing? Does that mean you modeled it bad, if that's the case? Or what does that mean? What does it mean when you have a proposal that is accepted but doesn't change the state, but it's important for the reactor? Like, in this case, does the reactor get the proposal as well? I guess it does. I would expect so, since it's like a callback here. So you could pick up ink by here as well, right? And then, as you said, that is fine. Like, and that, yeah, so that's my question. Is it fine that a proposal is not handled by an acceptor, but only a reactor? Yes, that is the question. So yeah, because that's basically what we were discussing in the app as well. It's like you have an action that doesn't change the state, but it's used by useTransitionEffect. Yeah, and then it's like, how do you? Yeah. So what's very nice here? Explicitness here. Yeah, what's nice here is that if you have a proposal that doesn't have an acceptor, like, you kind of see you still define the reaction to that proposal, but in like timsy, in like timsy or React states, you don't see that explicitly in the reducer because it's completely decoupled. Like, the reactor is completely decoupled from the acceptor, so you don't have that same understanding of ignoring the proposal as a way to change the state, but it's related to a side effect. So that's the thing. I just wanted to be more explicit. I wanted this to be, okay, I have this proposal for adding a to-do. It's perfectly valid, but I'm not going to do anything about it in terms of state. But there will be, but any subscription to the machine will react to this. And what I like about timsy not being a reducer in React is that in this case, you actually don't have to do this spreading. Like, you can just return the state and the subscription will still fire, because it's not constrained by React's reconciliation. It's subscription based. So this is a good way to think about it, I guess, is that you have a proposal, it doesn't change any state, so you just return the state. But again, it's like, why the hell do you have that to do there then? Yeah. Did you send me an email, Adam? Let me see. Where do I have my email? I don't think I have any secrets in my email. Yeah. Where the state don't really make sense. Yeah, with the use transition, where the state transitions to itself, doesn't really make sense to me. Yeah, exactly. That involve event-based programs, based transition. Does mean mental dump based on some things we have. This have all the scenarios. Yeah. 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 Yeah, I feel the same, Adam. It's like, there's something here. But yeah, this is, at least this doesn't have the burden of the mental dump of React reconciliation. This is timsy is more like, okay, you have an event. The acceptance is like the acceptance is just having the proposal on the state. In this case, this is how it's expressed, right? So just having add to do on foo is the acceptance. It just doesn't happen to change the state, but you accept the event. That's what we're expressing here. And unlike in React, you have to actually do this opposed to this to express if it's accepted or not, which is an extra burden. But that's not the case here. Yeah, that's one way to think about it. But it's still like, you don't guarantee that the add to do will be acted upon from within the machine. But that's kind of the point as well. Like, you have to choose, like, how much responsibility should the machine have? And the path I've chosen is that the machine only deals with state. That's the only responsibility it has. It doesn't dictate how the outside world deals with that state, which the command pattern does. With the command pattern, you actually, inside the machine, you say, outside world, do this. Which is not bad. It's just different. It's just added responsibility. So yeah. Okay, I have to wake up the little one, so he actually goes to sleep. I'm actually going to an assembly next week, going to the Netherlands to meet everyone at CodeSandbox for a week. So there won't be any streams next week. But what would be fun, I actually played around with this, is that what I like as a mental model here is that you have this low level subscription that gives state, event, and prev state. And on top of this subscription, we can do tons of cool stuff. Like, you could easily create like on enter state, for example. And what you would do is, so you would kind of make a generic to choose the state and stuff, but you would just subscribe to the thing, and you would so state. So you would just have state. You don't really care about the event, but you care about the prev state. So if, oh sorry, what should we call this? Okay, let's call it state, current, and prev. Maybe the order of the arguments here is a bit weird. But anyway, so you would just say current state equals state, and prev state does not equal the state, right? Because you only want to trigger it when you actually enter the state. If you happen to like be in the same state, you don't want to do anything. So now you suddenly can subscribe to on enter foo, and of course you would have a callback related to that, and then you would kind of trigger it like this. But my point is that we can have a lot of fun with this low level subscription, like creating all kinds of abstractions on top of it to react to the different transitions that happen. Whereas I had this useTransitionEffect, which is, I think, is quite powerful, as you can express, okay, when you enter this state, do this thing. If you enter, and even if you return something from this, it will dispose when it leaves that state. And then you can say, if you enter either of these states, run this logic, and when you enter some other state that is not foobar, then you will dispose. And then you could add like a second argument. So if you enter either of these states with the switch event, then run this function. So I think that's that's fun, like having that low level building block to create these very explicit subscriptions on top. And then you can like expose those subscriptions very easily. Like with React, it would be a useEffect. With Vue, it would be some other thing. And with Svelte, it would be some other thing. But the core is the same. Yeah. But anyways, the thing I like about timsy is there is no like typing of the state and actions. It's just implementing the freaking machine, and then you get the, like, of course you would type parameters here and here, but that's part of the implementation. It's not like describing the machine itself. Anyways, I'll make sure that this callback thing I changed is dealt with. Yeah, so that you actually pass the initial state and it's not a callback. And then I'll actually set us up for writing React tests. So I was thinking about like timsy/react, timsy/vue, and so on. And then, and you can argue like that should be handled differently, but package maintenance and multiple packages and versions, and I just don't have it in me. So at least that could be a start. So the next stream we could have like React, and we could try to consume timsy in React as a hook, and then expose different kinds of subscriptions as effects. That would be fun. That's a fun little project. Yes. And that's not to... I'll be in the Netherlands from tomorrow until Friday morning. But we'll be at like this location outside of Amsterdam with the team all the days. So, but I'll be back in Amsterdam later. Now that it's easier for me to hop on a plane, not just related to COVID, but also having tiny kids. So I'll be traveling more in the future. Are you close to the Netherlands? Adam, you're in Australia, aren't you? You're like on a different planet. By the way, I'm going to try to adjust the latency of the, like I can actually adjust the latency of the recording and YouTube so that we can have even more synchronous conversations. I'm not used to having this much interaction on the streams, so this is a lot of fun. So I'll try to improve the experience for everyone. But yeah, I really have to. This was a long stream. It's a good thing Oscar has been sleeping. Oh, you're in Amsterdam. Oh, that's awesome. You have to go and visit the offices at CodeSandbox, or the CodeSandbox offices. But yeah, I'm definitely coming back to Amsterdam. So we can meet up then and discuss Sam and timsy and everything. Yeah, what's the that's interesting. Let's see the recording, show recordings. Oh, I can't see it until I stop the stream. But I imagine like it's a 4K recording, so it's pretty big. Anyways, yeah, I'll tweet whenever the next stream is, and I'll try to prep it so we can play around with some abstractions. And what's nice is that we can try to use this concept, and I have tons of real life examples of state machines, like even the dev tools in React states. We have family Scrum, we have the Excalibur Firebase thing, we have CodeSandbox Projects. So we can take like very specific things and we can try to express it in timsy instead, and see what happens. Cool. Bye for now. Have a great Sunday, and we'll talk later. Thanks for the comment. Yeah, I just do this for fun. I can't help myself. So I'm glad to see that others have